So in this question, it says including the L1, L2, L infinity metric, let Rn be a Euclidean space and let xk with k equal m to infinity be a sequence of points in Rn. That the following four statements are equivalent. And we need to prove these four statements such that part A, it says converges, the sequence converges to x with respect to the L2 metric, the sequence converges to the L1 metric, the sequence converges to the L infinity metric, and as well as for every j between 1 and n, the sequence xj of k converges to xj. So let's state our assumption here for the entire proof. Let the sequence be a set of points in Rn such that it's equal to this, as well as x is going to equal to this right here for all for all n points or n dimensions in Rn. So I think these two properties, as well as identities and lemmas, are very important to proving this, and we prove these in past problems. So I want to show that if the sequence converges to x with respect to the L2 metric, this implies that the sequence converges to x with respect to the L1 metrics. So we know that the sequence converging to x with respect to L2 metrics implies that the limit of sk approaches infinity, this is with metric of L2 for xk, sequence xk to x is equal to 0. And we didn't notice here that for this formula here, root n is a constant for every Rn term, right? It's always a constant for every nth case. And so basically I can use this inequality and basically use this inequality over here and say that root n dl2 of this is less than or equal to this term right here. I can then converge this over here, and this implies that this is equal to 0, which being multiplied by root n is equal to 0 as well, which is less than or equal to this, right? And we know that any distance metric is always greater or equal to 0 by squeeze theorem. This implies that this is equal to 0 as well. So now I want to show that if the sequence converges to x with respect to the L1 metrics, this implies that the sequence converging to x with respect to the L infinity metrics. So again, knowing the definition of convergence, I can basically know that the limit sk approaches infinity of the x of k and of x in respect to the L1 metric right here is equal to 0. Again, previously seen, we can use the inequality right here that we proved in the last in the beginning portion, and we can basically see by using squeeze theorem right here that this is equal to 0. Next, I want to show that the sequence converging to x in respect to the L infinity metrics implies that the sequence converging to x implies that the sequence will converge to x in respect to the L2 metric. So again, it's pretty trivial right here. This is just a constant, 1 over root n, as well as this is a convergent area, then I know that this is a convergent area too. So basically, see, I can do this is equal to 0, less than or equal to this, right? I can then show that this is less than or equal to this, which is less than or equal to 0, right here, which implies that this is equal to 0 as well. Therefore, I have proved that A implies B implies C for this statement. So for this question, I want to prove B if and only if D. So if the sequence converges to x with L1, this implies D. Let me read D again. For every j between 1 and n, the sequence x of j of k converges to x of j. And right here it says, notice that this is a sequence of real numbers, not of points in Rn. So again, converging to x in L1 implies that between the sequence xk and x right here, that should say x right there, is equal to 0. And I can basically imply that all of this is greater or equal to 0, right? And by using the squeeze theorem, I can then imply that for all of these elements right here, every individual x of k is equal to 0, which implies D. Now I want to prove D implies x of k, converging to x in L1. So again, let me just unpack the definition of what D is saying right here. Individually, these are all points that converge to 0. Alright, for this part, I'm assuming that the distance metric for this convergence is going to be the normal absolute value function, which I think is fair because what else would it be? Is equal to 0. This is then greater or equal to 0 right here. And by using squeeze theorem, it's equal to 0 right here. And because I'm adding up all these terms that are 0, right? And so adding up 0 again is 0. And so then I know that this is converging to x with d L1 because this is the L1 metric right here. Thus, B implies D and D implies B right here. And since I proved A implies B implies C, the following are equivalent has been proven to be true.